6.5 is solving square root and other radical equations. We're going to start off with solving square root equations, and then we'll be taking a look at radical equations, so when we're using our exponents. So to start off with, the first problem we're going to take a look at is 3 plus the square root of 2x minus 3 equals 8. So for these problems, we want to get the square root symbol by itself. So anything that is on the ends, that is added or subtracted or multiplied to it, we want to move that to the other side, so we just have the square root and what's underneath of it by itself. So this 3 is positive, we're going to go ahead and subtract 3 from both sides. These 3's will cancel out, so we get 8 minus 3 and 5. And then we have the square root of 2x minus 3 equals 5. How we undo the square root symbol, we're going to square both sides. The square and the square root just cancel one another out. So we have 2x minus 3 equals, then 5 squared is 25. And then we just go ahead and solve this two-step equation. So we're going to add 3 to both sides. The 3's cancel out, so we have 2x equals 28. And then we're going to go ahead and divide both sides by 2. So the 2's cancel out, so we get x equals 4. Now the second problem, we, again, first step, want to get the radical by itself. So this minus 5 on the end, we're going to go ahead and add 5 to both sides. So those just cancel out. So we have the square root of 4x plus 1 equals 5. To undo the square root symbol, we square both sides. The square and the square root just cancel out, so we get 4x plus 1 equals 25. And then we solve this two-step equation, so minus 1 on both sides. So we get 4x equals 24. Divide both sides by 4, we get x equals 6. The nice thing about these equations, if we're second guessing our answer, just go ahead and plug that back into the original equation, simplify both sides, and see if both sides equal the same. So 4 times 6, we get 24, plus 1 is 25, square root of 25 is 5, 5 minus 5, we get 0. Both sides don't equal the same, you know you have the wrong solution, that you need to go back and look through your work. Alrighty, the next type of problem we're going to take a look at is solving other radical equations. So for this one, we have 3 times x plus 1 to the 2/3 power equals 12. First thing that I like to look at for my exponent, I want to check the numerator to see if it is even or odd. If it is an even number like this, I'm going to have 2 solutions. If it is an odd number, then I know I'm just going to get one solution. So this one, we need to be getting 2 different solutions. So same as above, we want to get this set of parentheses by itself, just like the radical up here. So it's 3 times this, so we're going to go ahead and divide both sides by 3, so those 3's cancel out. So then we get x plus 1 to the 2/3 power equals 4. And then how we undo to the 2/3 power, we're going to take it to the reciprocal power. So instead of 2/3, take 3/2 power. And we're going to take that on both sides. Number times its reciprocal just gives us 1, so it cancels out like the square and the square root. So then we just get that x plus 1. And then 4 to the 3/2 power, we can put that into our calculator if we want to. And we get that 8. And how we would do that, if you're wanting to do that on the calculator, you would just go 4 caret and then to the 3/2 power. And I would put that 3/2 inside parentheses. But that caret button is right underneath the clear button, right above the division sign. Click enter, and we get 8. And then since we know we're going to get 2 solutions, it's plus or minus 8. And then we go ahead and solve it. So minus 1, so we get negative 1 plus or minus 8. So how we get our 2 answers, if we add negative 1 plus 8, we get 7. If we subtract negative 1 minus 8, we get negative 9. Alrighty, this next one, again, we're going to want to get this radical by itself, so minus 1 on both sides, and then we get 24. Divide both sides by 3, so those cancel out, we get 8. And then I would switch this one to exponential form, so I have x plus 1 to the 3/5 power. And then from here, how we undo to the 3/5 power, we're going to take it to the reciprocal power, so 5/3 power on both sides. And then the number times its reciprocal is just going to cancel out and give us x plus 1. And then 8 to the 5/3 power, if we put that into our calculator, we get 32. Solve this equation, minus 1, we get x equals 31. Notice on this problem I didn't put that plus or minus sign, and the reason for it, right when I put it in exponential form, again, I'm going to look at that numerator of our fraction, and it's 3. It's an odd number for our numerator, so I'm just going to get one solution. Okay, the next problem, I'm going to go ahead and divide both sides by 2. So I get x plus 3 to the 2/3 power equals 4. And then I take it to the reciprocal power. And so those just cancel out. I get x plus 3 to the 4 to the 3/2 power is 8. Notice this one, I need that plus or minus because the original fraction, the numerator is even, so it's going to have two solutions. Then minus 3 on both sides, so I get negative 3 plus or minus 8. Negative 3 plus 8 is 5. Negative 3 minus 8 is negative 11. And again, if I want to plug those solutions back in for my x, simplify both sides should equal the same. Now the last type of problem we're going to take a look at in this section is checking for extraneous solutions. So extraneous solutions just means extras. Even though all of our work shows that it should work out, when we plug it back in, it does not work out. So we want to make sure when it says check for extraneous solutions, we're actually plugging those back in. Both of the solutions could work. Maybe one works and one doesn't work, or maybe both of them does not work. So to start off with, for number 1, we have the square root of x plus 7 minus 5 equals our x. So we're going to get this radical by itself, so we're going to add 5 on both sides. These are not like terms, so we're just going to put them next to each other, x plus 5. And then how we undo the square and the square root, so those cancel out. We get x plus 7 equals, and then this part, don't just think it's x squared plus 5 squared. That's going to be a common error. X plus 5 squared means that I'm writing that twice, x plus 5 times x plus 5. So I'm going to actually have to distribute or FOIL on the right-hand side. So x times x is x squared, x times 5 is 5x, 5 times x is 5x, 5 times 5 is 25. And then I'm going to want to go ahead and combine like terms, get everything set equal to 0. So then I'm going to subtract the x over, subtract the 7 over, those cancel out. Start combining my like terms. I have x squared, 5x plus 5x is 10x, minus 1x is 9x, and then 25 minus my 7 is 18. So then when I set it equal to 0, I have a couple different options. I could go ahead and graph this, see where it crosses the x-axis. I could go ahead and use the quadratic formula, label my a, my b, and my c, or you can go ahead and factor it if you like factoring. So if I choose factoring, I need to see 1 times 18, what multiplies to 18 but adds up to 9. So I have 1 and 18, 2 and 9, 3 and 6. It has to add up to 9, so I'm going to need the positive 3 and positive 6. So I put that in parentheses, and then I'm going to set both of them equal to 0 to solve for them. So this first one I get negative 3, and the second one I get negative 6. So how I'm going to check these solutions, I'm going to plug in negative 3 back in for my x's. So negative 3 plus 7, I get 4. Square root of 4 is 2. 2 minus 5 is negative 3. Both sides reduce down to the same, so that one ends up working out. Now I'm going to plug back in negative 6. Negative 6 plus 7 is 1. Square root of 1 is 1. 1 minus 5 is negative 4. Notice I don't get the same on both sides. So then this one is extraneous, so I'm just going to X this one out to indicate that it's extraneous. This next one, to start off with, I need to subtract the 3, so those cancel out. These are not like terms, so I just put them next to each other, x minus 3. I want to undo the square root sign, so I square both sides. The square and the square root just cancel out. So I have 5x minus 1 equals, and then this I'm going to have x minus 3 times x minus 3. So notice you're going to have to go ahead and distribute. X times x is x squared. X times negative 3 is negative 3x. negative 3x, and then positive 9. And then I'm going to get it all set equal to 0 and combine my like terms. So I'm going to subtract the 5x over, add the 1 over, those cancel. So I have x squared. Negative 3x minus 3x is negative 6x, minus the 5x is negative 11x. 9 plus the 1 then gives me 10. And then again, you can either use the quadratic formula, graph it and see where it crosses the x-axis, or factor it. If I go ahead and factor, I get 1 times 10 is 10. I'm thinking what multiplies to 10 but adds up to negative 11. So 1 and 10, they both have to be negative. So I plug that in, set them equal to 0, I get 10 and 1. So if I'm going to go and plug this back in, I plug in the 10 right here. 5 times 10 is 50, minus 1 is 49. Square root of 49 is 7. 7 plus 3 is 10 on this side. On this side, if I plug in the 10, I get 10. So both sides equal 10, so this one works. Now plug in the 1. 5 times 1 is 5, minus the 1 is 4. Square root of 4 is 2. 2 plus 3 is 5. I get 5 on the left side. And then notice if I plug this on the right side, I just get 1. 5 does not equal 1. So then that one's my extraneous solution. One last problem that we're going to go through. So this one has 2 radicals. So we want to just get this radical by itself. So add the square root of x over to the other side. These cancel out. They're not like terms, so I'm just going to write them next to each other. And then I'm going to keep doing what I have been doing, square both sides. So these cancel out. So I get 2x plus 1 equals, and then this side I'm going to have to FOIL or distribute. So I'm going to write it again. 1 times 1 is 1. 1 times square root of 7 is 1 square root of 7. Square root of 7 times 1. Or square root of x times 1 is 1 square root of x. Square root of x times square root of x is square root of x squared. The square and the square root cancel out. Or I have a pair of x's, so I just get x. I need to simplify this. And so 1 square root of x plus 1 square root of x is 2 square root of x. Get it all. Instead of setting this one equal to 0, we're going to want to do this one a little bit differently. We're probably going to want to get this square root by itself. So subtract the 1 over, those cancel out. Those actually cancel out, so that's nice. So we get 2 equals 2 square root of x plus x. I'm going to subtract the x over. So 2x minus x is just 1x, or x equals 2 square root of x. And then this one, I need to get rid of that square root symbol, so I'm going to square both sides, so the square and the square root just cancel out. So I get x squared, and then 2 squared is 4. Square and the square root just cancel, so x, so 4x. And I needed to square both of these because they were both in parentheses. So I get x squared equals 4x. I'm going to now set it equal to 0, so minus 4x on both sides. And then if I factor out the x out of both of them, I get x times x minus 4. Set them both equal to 0, solve for them, I get 0 and 4. For this one, if I plug them back in, let's see if they both work. 2 times 0 is 2, plus 1 is the square root of 3. Oh, just a second. I did that wrong. 2 times 0 is 0, plus 1 is 1. Square root of 1 is 1. Minus square root of 0 is 0, so 1 minus 0 is 1. So this one works out. Plug in the 4. 2 times 4 is 8. 8 plus 1 is 9. Square root of 9 is 3. Minus square root of 4 is 2. So 3 minus 2 is 1. Both of these end up working.